Hello everyone, and welcome to our project demonstration. My name is Golan, and my partner is Amit Sandak. We are students at the College of Management Academic Studies, and our lecturer is Eliyahu Khalsachi. In this demonstration, we will introduce our features and will try to illustrate the challenges we experienced during the project. Our project was a 3D maze game, which includes generating and searching algorithms, client-server decoupling, and more. For example, in order to offer a wide variety of mazes in the game, we had to look for an algorithm that will support maze generation. We chose the recursive backtracker algorithm. This will allow us to generate a maze in any size we desire. Another example, we implemented two searching algorithms, the BFS and the A-star, which is an extension of the BFS. The A-star uses different heuristics in order to determine the best possible solution courses. In this project, we use the air distance and the Manhattan heuristics. In order to keep our project generic and to support architectural flexibility, we implemented an object-oriented programming structure that separates the problem from the solving unit. This flexibility will allow us to import different search algorithms or to export our algorithms to different projects. Enough with the theory, let's move on to the results.
Hi everyone, my name is Amit. First, we need to run the server. The client connecting to the server during his startup process. The server details and some more settings are loaded from an XML file and define the program behavior. Let's ask from the server for a new maze. And now let's ask for another one from the second client. Look, the server deals with both clients concurrently. Now we will ask for a maze that the server is already generated in the past. We want to show you that the server manages a cache in order to be efficient. As you can see, the mazes are identical. This is the time to say that the client also stores a cache in order to reduce the traffic. Okay, let's play a bit. Look how Pac-Man turns and rotates through the maze. Let's look at the widgets. They designed in order to help us to navigate in the maze. The arrows show us the possible moves in the maze. The cube gives us a proportion to our location in the maze. And this cool widget switches the view between the different cross-sections of the maze. And for dessert, if you want to look closer, you can play with the mouse wheel. Wow, this maze is difficult. Let's ask for a clue. Okay, I give up. What is the solution? Cool. Pac-Man is now walking alone to the goal. I love this maze. Let's save it and play it again in the future. As we said, our program properties are managed in an XML file. In this menu, we can generate or reload different settings. Let's change the UI setting to the command line and let's see what will happen. Notice, we switched from one UI to another during runtime. It's amazing. Now, let's move on to the server side. Guy, please take it from here.
In our project, we use some design patterns. Let's focus on one for example. In the client side, we use the MVP architectural pattern. This pattern allows us to design and build every unit separately. The main principle about the MVP is that the view and the model units are working together without actually knowing one another. This is implemented via the observer pattern. The view and model are the observables, and the presenter is the observer. In this slide, you can see the general project diagram. Observe how the game client, the server, and the management application are individual programs. The connection between them is through a network channel. It allows us to be able to close the management app and leave the server to run as a service. And even more, we can now manage the server from many different management applications. This allows us to manage the server remotely from another computer. Let's see this working. The server is already running, but as we said before, to manage it, we need a management application. So let's open one. This form is a generic one. No matter which class you throw at it, it will build the user interface, collect the data you entered, and builds you an entirely new instance of the given object. On the left table, we can see exactly who is connected to the server right now. And on the right table, we can see an event log which tells you exactly what is happening in our server. For example, we can see the client is asking the server for a solution exactly when he does it. How wonderful. This button allows me to remove a client from the service. He will not be able to generate or solve new mazes, but he will still be able to play with the ones he already got. In this area, we can see the service status and control it. Notice how, when I shut down the service from this app, you can trace the closing process in the log. This button will shut down the server entirely. Notice how all the threads are terminated. This was executed in an orderly fashion. Did you see that the management application was also switched off? This is because you simply cannot manage a server that does not exist. As we said before, the server autosaves all the mazes and solutions and stores it for future use.
We hope you enjoyed and thank you for watching us.